So, good morning. So the goal today, as we said on Wednesday, would be to finish this hypothesis testing. And so, I guess, although just 2 days, I know you guys are very busy, so I think it would be necessary for us to review a little bit of what we have covered last time very quickly. So, and then we proceed to finish all this thing. I mean, the goal is to finish hypothesis testing, and then you will see the last assignment will be released on, after the deadline of current one, which is, I think, Saturday. I supposed to have the assignment for the last two topics, but I guess you won't have time to finish it. So the last one will be, I'll release it, but you will be, answer will be released later. So the very last one will be optional. Just want to do it. But will not be checked or graded, whatever, but just release the result as well. So let's repeat a little bit what we have been doing. Hypothesis testing is you have some idea or you think what might be the population parameter is. Okay, in this case, it's mean. Okay, and testing the mean is something very important because when estimate a model, the model parameter, the mean, right? So you want to see whether the parameter actually equals 0 or not. So that would be something we'll use. We'll talk about next week when we have ANOVA model and also regression model. And the cases that we will be working on. Okay. So the main idea is like this, right? We have null hypothesis. Mu is equal to a certain value, or mu is not equal to or less than or more than. So we want to see the data would favor the alternative hypothesis. Okay. And then let's quickly go into the alpha, right? Because alpha, the type 1 error, would tell us that when you would reject and when we not, right? Under the null hypothesis, right? Because that is the acceptable region where you would say where is a sampling mistake, okay, is not going to tolerate, right? Because that is idea is how far away from the null is considered as the evident enough to support the alternative, right? So, and the p-value will be the probability that or the smallest alpha that you reject, right? So let me quickly redo the example here, right? This is the set test, right? Remember, set test is the case where you're given the sigma, okay? Let me do free exercise. I do the two-sided set test and two-sided t-test and the proportion as a freely the example that you will find in your assignment as well. So let me quickly go into this one, okay? Again, we know the population follow the normal, okay, with SD4, okay? And assuming the null is 6, that means that we have a X bar is well a bell curve, okay? With the mean 6 here, okay? And this depends on, the variance depends on this, right? And of course, the standard error will be this guy, right? The question again would be, what is the meaning of 5 here? Okay. Is it 5 far away from 6 enough so that you say 6 is unlikely, right? So our rule would say if we use 5% significance level, it means that we would say, okay, we are tolerating 5% error for type 1 error. So this will be 0.025. This will be 0.025, right? So that would be the idea. The question is whether 5 is in this area or not, okay? So that if 5 is in the area of rejection, which is the pink area, then we will say H now is rejected with 5% significance level. If not, then we are not rejecting, okay? So that is the main idea. And of course, we know sigma, we know n, then basically we know where 5 is, right? Because the bell curve, right? And the classical case is we do not work this directly, but instead we work on the set, right? And this 6 become 0. And what is 5 here? 5 is -2. And what's this guy, right? How to get this? It's called set test statistics, right? Will be 5 minus 6. That is the difference between 5 and 6, right? And you divide it by how many SD standard error, which is this guy. The standard error is 4 over square root of 64, which is actually 1/2, okay? So that's why it's -2, okay? So the question would be, you want to calculate this area, right? And multiply by 2, right? Because that would be the smallest alpha that you reject, right? And this area is given by normal dot s dot dist -2 true, okay? And remember, we want, because two-sided test, we have to do times 2 because we want to find the smallest alpha that reject, right? And this alpha is alpha over 2, right? So that's why it's 2 times. And this turned out to be 4%. So if you use 5% surface level, then you would reject the null. If you use 10%, also reject. 1%, not yet. Okay. If you use 1% very small, then you're not yet. Okay. And this is what they call the p-value method. You calculate p-value and compare to your alpha. The other way we said we can do is what we call the critical value method, right? And it's to calculate where is actually the rejection region was a critical value here, right? So this is the value of 0.025. This is size is 0.025. Okay. And this is the norm S dot inverse 0.025, right? And this guy will be norm dot S dot inverse 0.975. Why 0.975? Because 1 minus 0.025, because inverse is calculating from the left-hand side area. So this will give you 1.96. The other will give you negative 1.96. And you will see the 2 is actually, so this is negative 1.96. And this is 1.96. And your 2 is actually here, -2, right? So this is it in the rejection region. Then we'll say that actually 5 is different from 6. It's far away enough. So you would reject the H0 in favor of H1. Okay? So that's the idea. Just to remind you that this hypothesis testing is very useful. First, I said in a lot of application like audit or court system, you actually do this kind of procedure, right? Quality check. And second is when you do estimation, you estimate parameter model, and you estimate the mean of this number, and want to test whether this value, right, is the parameter value equal to 0 or not. You will see this very carefully when you talk about ANOVA and regression in the next 2 weeks as our last two topics for our class. So that would be very important. Is that okay? If that's okay, then I'll call about the t-test again. Okay, a two-sided t-test. Okay, for both tail. Okay, so the idea would be very similar. Okay, again, this is normal. Okay, it implies that our sample mean is also follow a bell curve. Okay, that is the main idea. And of course, the mean will be same as the population mean. Okay, and we're testing whether it's equal to 4, so it's 4 here. Okay, and the idea that right with the bell curve, and then the variance of this is sigma square over n, and the standard error would be sigma over root n, right? So that is something we know very well from our topic 4, right? So what is left is, okay, our data tell us is 3, right? And remember what we're testing is whether it's equal to not equal to 4, right? Again, you would put alpha over 2 on the both sides, right? Okay. And alpha is 5%, then it's 2.5 on the both sides. The question again we're asking if our x bar is actually 3, right? X bar is 3. So is it going to be here or going to be here, right? Our 3 is, where's 3? Okay. Of course, 3 in the pink area, you reject the H now. If it's not in the pink area, you do not, right? So that is something not terribly difficult. But the problem of this is we actually don't know sigma square, okay? Or sigma. So we don't know actually the area, right? We don't actually 3 is in the pink or not, okay? If you don't know sigma square. So luckily, if you remember, because we assume normal, okay? Even though we don't know this, okay? We can calculate the sample standard deviation, okay? And that, remember, S is a good guess to our sigma, right? And under the normal, right? We know that although we don't know this guy, but we can exactly know the shape of the T statistics, okay, which is T15, which is n minus 1, right? By replacing this by S, then you can draw this, right? So basically, with the T15, right, the 4 is actually becomes 0 here, okay? And the 3, right, what is the 3 here? Okay. The 3 here is basically coming from 3 minus 4, right, which is the distance to the mean, right? And over the standard error, which replace S to sigma, would be S would be 2 over root n is 16. So again, this is the estimated standard error is S over root n, which is 2 over root 16, or root 16. So it's equal to 1/2, right? So it's, again, this is negative 2. Okay. So the idea that we have negative 2 here, and we know it's T15. 15 is come from 16 minus 1. So it's a two-sided test. So that's why I look at adjusting the alpha to just reject it's a p-value. So I just need to calculate this area times 2, right? This area times 2 will be just the alpha we got this reject. Okay. And how to calculate this area times 2, right, will be the norm S dot this negative 2. Oh, sorry. It's not normal, right? So not, sorry, not norm SD. So it would be T this negative 2, 15 table, because T has many tables starting from 1 to infinity. So we took the 15 one. The 15th table, true. Okay. And because of two-sided, we use two-sided. Okay. And this number turned out to be 6%. What does that mean? It means that if you use 5%, it's not enough to rule out it's due to some sampling problem, right? Because that would be, even the H now is true, right? It still can have 6% end up here, right? So it's not small enough. So 3 is not far away enough from 4. Okay? So you will keep H now. Okay? So in this case, is the defendant is not yet guilty yet, right? The evidence is not sufficient to prove beyond reasonable doubt. Okay? There are some doubts over there. It's called the p-value. If you don't like p-value, you can also do the critical value method. What's T15 here? Okay. And what should be the 2.5% here on the both, right? And this line will be T inverse 0.025, 15, right? And this would be T inverse 0.975, 15, okay? And they are positive, negative 2.1314, okay? So that would be the idea behind all this, okay? I hope I work on this because these are just basically very mechanical, right? But at the end of the day, just remember in your life, in the future, you only see the p-value in your computer. Okay, just better compare this two. But you will wonder why we use this p-value, why we just compare 5%, and that is the logic behind. That's why I keep doing this, because I want to stick it in your mind what actually we are doing, right? Because when actually in the future, you will not do this exercise. You just look at the p-value, more than 5, less than 5%. But I want you to know what's the reasoning. Why is just look at 5% and you're done, right? And that's important, right? Because now with AI, everyone knows what's going on very quickly, right? But you need to understand what's the reasoning behind, because the calculation is already automated, right? And why you can earn more than others, right? It's because you know whether the AI is doing right or wrong, right? You are not actually doing all the calculation, but you do understand how to apply it, how to use it, right? How to set up the null hypothesis, right? Why they are true, right? Because AI may not always right all the time, right? You have to know whether they are doing right or wrong. So the principle is very important, not the calculation. Okay. But anyway, I hope you understand why we spend so much time on drawing this all the time, right? I guess this is the only time in my whole year would draw and write something. This day I just do computer to type stuff, but this is the only time in the year I actually draw and write something. I mean, in other classes I didn't draw anything, right? Very rarely I write something, but this is the few of the courses I want to stick this in your mind. Okay. But anyhow, I hope you remember the Z test and the T test. Okay. They are testing the population mean, and Z test is when you have the sigma, and T test you don't. Okay. And of course you ask, when I know sigma, but you never know. But many times that you have a good estimate of the sigma. All right. Many times you have, because you can be sigma from an engineering perspective, right? And also maybe coming from a good guess is coming from historical data. Okay. But anyway, why Z test is there? Because remember the proportion, but the binary data, you can always use the norm Z test, right? Because when we hypothesize the mean, we know the variance. Okay. Let me go to this last example. Okay. Because that would be, and then we go to the two sample test. Okay. So we have binary data. So remember what's binary data is bunch of yes, no question. Okay. For example, it is asking whether you like particular Korean pop star? Yes or no? Right? So in this particular case, I want to know to check if the proportion is actually 40%, right? And on the check against it's not 40%, right? So we know that this is population mean, right, or proportion, right? But I use the sample proportion, which will be a random variable, right? Because this is exactly the X bar, right? This is actually the mu, right? So it will be a bell curve, right? At the center of 0.4, because that is what we think is true, right? And we know that if this is 0.4, right, the spread, because the binary data, we must be 0.4, the variance, 1 minus 0.4 over n is 50, right? Suppose n is 50, right? So that would be the spread of this, right? So it's very nice, right? Because when I take a bound data, if I know the location of the mean, I know the variance already. So that is something pretty interesting, okay? And I want to check if this is 0.4 or not, right? So it means that I would have the type 1 error, right? Alpha on the both sides was 0.025, okay? And the question would be, the data shows is half of the people like the Korean songs, right? Then the question is 0.5, is it actually here or actually here, right? The question is 0.5 is which one, okay? The 0.5 is in the red area, then you reject HNO. If not, then you don't, right? So that is pretty standard. And actually, we know the spread actually can calculate directly, right? Because we know how spread is. But it's customary to convert it to the Z space, right? This become 0. Okay? And what is 0.5? 0.5 will be just the distance over the SD, right? So it's 0.5 over 0.4 square root 0.4, 1 minus 0.4 over 50, right? So this turns out to 1.44, right? It's something you can easily calculate, right? But as I said, don't worry, all this thing is actually automated in all the software system, or even Excel can do it. Okay. If you give the data, later you see the Excel automatically will p-value. Okay. So the question is, the p-value method will ask this area times 2, right? Because it's two cell tests. Area times 2, is it more than 5% or not? Okay. Suppose it's 5%. So this area, because the bell curve will be the norm as this 1.44 true. But remember, this is not the area you want because the area on the left-hand side. So you subtract 1 from it, become the left-hand side. But this is not done yet because there's only area on the right-hand side. You are comparing this to alpha over 2. So that's why you need to multiply 2, then you compare to alpha directly. So that's why this 2. And this gives you 14%. Okay. And 14%, no way you would reject the null because the standard is 10%, 5%, or 1%. None of them will say 14% or 15%, right? It's going to be saying this 0.5 is still within the marginal error, right? So the question probably you ask, what can we do? Collect more data. If you want to reject it, you say 0.5 actually is different from 0.4, right? Why can't reject? But because of you need more data, right? 50 is not enough. Okay, you need more. Okay, so the question of some of you ask for your project is how many sample you need, right? Then of course, if you think it's not 0.4, then probably you want to collect more data, right? In this case, right? It's not yet reject, right? So probably you can still collect more data to see if you can reject it or not. Okay? So if there's no question, then I'll go to the 2 sample tests because that will be the main goal of today. Let's just finish the review. Okay. The main goal today is to finish all this, okay? And don't worry, they are all closely related to what we have covered before, okay? Before, we just talked about 1 sample case. Now we talk about 2 sample, and at the end of the day, actually, we are converting 2 sample into 1 sample idea. We only still end up with 1 bell curve, okay? Although 2 bell curve, but we'll combine it into 1, okay? And that will be the goal, and then everything is a little bit straightforward, okay? Only the very last one, but that one is very simple. Is actually we're talking about comparing variances. But otherwise, the first 4 are pretty straightforward. It's nothing new there. You still comparing the bell curve, okay? But you look at different standard error, look at different degree of freedom to check. Okay, so but let's start, okay? The main idea, let me draw it again in case you can't recall. 2 population means that I have, say, population 1, okay? Okay, we have a group of women, okay? And they have some bell, the population, okay, would follow the mean mu1, right? And the variance of sigma 1 square, right? This will be the x1, right? If you draw 1 guys, right? And but that also means that it is a bell curve. The x1 bar will be mu1, okay? But the variance is mu1 square and 1. So do note that I draw in this way, they're very different. This, okay, is I just draw 1 guy, randomly draw 1 guy. It's a bell curve, right? And that actually because of population. But this, I draw n guy, then will be n1 people, then will be like this, right? So if I randomly draw the first one, then will be x1, 1. Second guy will be x1, 2. And the data I have is x1 and 1, right? So that would be the idea behind this. Okay, that's a bell curve, right? And similarly, we have population 2 and bunch of men, right? And we'll have the population 2. And our random sample will be x1, x2, 1, x2, 2, and up to x2 and 2, right? We have the same idea. This is the bell curve, right? Mu2, sigma 2 square, and the sample mean, right, of this, right? You draw it with something mu2, sigma 2 square over n2, right? So that will be the key. So the thing we want to see, right? Remember what we're trying to look at is we want to check if mu1 is actually equal to mu2, right? Because, for example, we want to say for marketing exercise, we want to say whether man and woman would like to spend the same amount on your product, right? And if the same, then you need not catering concern different market. If men and women have different willingness to pay, then you would segment the market, right? So if men more willing to pay more, then probably you would try to targeting more men, right? You will sell to more men. If women want to pay more, then probably your sales effort would target into women, right? Because suppose you see, let's say 1 man, 1 woman on the road. If you are men wanting to spend more, then you talk to the man, right? The same idea, because the resources constraint, you can't talk to both, right? If you have a lot of money, then of course talk to both, but it's more efficient to talk to the customer that would willing to spend more. And we want to test this is the same or this is not the same, right? And how do we test this? The idea is to look at this is a bell curve, right? And we can ask ourselves, if this is true, right? That means that if you take the difference between the sample mean, okay, the difference of the two bells, okay, of course, will be mu1 minus mu2, right? Because two bell, this is also a bell curve, right? As we learned, right? And if this is true, this is 0, right? It will be, the bell will be centered at 0, okay? And if you recall, if this is normal, the variance, it just add up, right? Just add up the, what is the variance of this is sigma 1 square over n1 plus sigma 2 square over n2, okay? So that would be the idea, okay? And the question is, when you reject, right? So here I have two side tests, okay? You can do one-sided, but to be general, I do two-sided because two-sided the most the time we do. That means that if this is belong this area, alpha of 2, then you would reject, right? So the question is, if I know sigma 1, sigma 2, then there's a simple z-test is done, right? So this, because it's a bell curve, we are done, right? It's a z-test. The only troublesome is I don't know sigma 1 and sigma 2, okay? And I have to rely on S1, S2, right? So I would rely on the sample S1 square to guess this guy, S2 square to this guy, right? So that would be very natural thing to think, right? And that will be covered later, okay? That will be one way to do it, okay? And but of course, if you do this, the difficult part is what is the T table we look at, okay? That will be more complicated. So that's why instead of looking at these more general cases, we would consider a case where sigma 1 equals sigma 2, okay? In the case that sigma 1 square equal to sigma 2 square equal to, say, sigma, okay? They are same. If I know they're same, which might be true in many cases, but you have to check whether it's true or not later at the end of today. We'll talk about F test that can see whether it's true or not. Okay, this can be testable. Okay, we can check it. Okay, this can be checked. Okay, but assume it's true, then you will see S1 square or S2 square is both a good estimator of sigma square. Okay, they're all unbiased. They're both of them unbiased. But you can use them, there's no problem. But the problem is it's not the most efficient, not the best one. Okay, you want to find the best one. And the best one turned out to be, okay, is we call SP, okay, will be just how a combine of them, okay? How combine? It depends on how many samples you got, right? If you have more N1, okay, then you trust more 1, right? You have N2, you trust more N2, right? So that is weighted average. The ratio is N1 over N2, right? And of course, it just weighted average, so just add up all the weights, right? So it's a weighted average with weighting equal to N1 minus 1 and N2 minus 1. Okay. So in the slide, I didn't go over. There's a proof there why this is the best okay? And I'm not going to do it, but you are going to use SP to estimate this sigma, okay? And then that means that once I replace this, I can go to the T, which is N1 plus N2 minus 2, and I draw this guy, okay? And everything I can check accordingly, okay? So basically just once I play this, it's standard t-test, right? I do a t-test on this. So that's the idea. Okay? So, and if I drop this assumption, then I will use what I see in above, okay? So I tell you this last class. So let's us actually get to the exercise, okay? Or sorry, get to the example to show you how to do that, okay? So this is the question again, is I have a two population, imagine it's male, woman, and man, maybe, right? And I know that for my data, okay, let me just draw it here. Okay. I have a woman, right, willing to spend on average $40 on my product, okay? And the standard SD is 4. And how many women I asked? 50 women, okay? And I also asked men, how many men I have? N2 is 40. How much they want to spend on average? $42. What is SD? Is 3. Okay. So I want to see if men are willing to spend more or women spend more. Okay. So remember the hypothesis is man and the woman are same or not, right? Because why I want to do that is I want to see if I need to segment the market, right? This is my application, okay? So recall that everything is normal, okay? If everything is normal, x1 bar minus x2 bar is also a normal, okay? And we know the center of this bell, according to this, will be 0 because they're same. So difference of the two bell will be located as center 0. And we know how spread out is this data, right? The variance will be sigma 1 square over n1 and sigma square n sigma over n2. And already we told you that at the current moment, we think the man and woman are the same. So we have actually sigma square over n1 and sigma square over n2. Okay. So that's the idea. And we're saying that we are rejecting if they're not equal. So that means that we put alpha over to here, alpha over to here. Okay. And from your data, look at it is 40 minus 42. Okay. So it's actually -2. Okay. The -2 is either here or here, right? So if in the pink region, then you reject. If outside the pink region, then you not, right? So that's very simple because the question is -2 far away from 0? And how far it is looking at how likely that is happening, right? And if we know the sigma square, then we're done immediately now, right? But the problem is we don't know sigma square, okay? So in this particular case, we know what's the best guess for sigma square is the formula we call the pooled variance, SP square, okay? Is the weighted average of S1 and S2, okay? And that is, the weights depends on the sample size. N1 minus 1 is the weight of 1. And N2 minus 1 is the weight of 2, right? And the denominator is sum of the weights. So it's N1 minus 1 plus N2 minus 1, right? Just add them up. N1 minus 1 plus N2 minus 1, okay? And this is something close to 12, okay? Remember, this is 16 and this is 9. 12 is somewhere in the middle, okay? Because, and you can see if N1 is very large, then this will be close to 16. If N2 is very large relative to N1, will be close to 9. So it's just because you have two sample variance, it must be somewhere in the middle. And once we know this, then life is easy, right? Because we know this with T, N1 plus N2 minus 2. This is T 88, okay? Because 40 plus 50, right? And of course, this screen go to 0 again, right? And the question is, what is 2 here? What's the negative 2 here? Okay. And that is asking how many standard error below the mean, right? Away from mean. So this number, we learned that will be negative 2 minus 0 over what? The square root of this guy, right? The square root of this 12 over 50 plus 12 over 40, right? And what's the number there? To be more exact, it's negative 2.6. Negative 2.6. Okay? So the question is this far away from 0, right? Again, you can use the p-value to decide is it far away or not, right? So that would be, looking at this number, right? That would be T, this, negative 2.67, true. Okay? And then you multiply by 2 because I do the two-tail. Okay? And turn out that this is less than 5%. What's the number? Look at the slide I got is 1%. Okay? This is 0.0 or 0.01. Okay? And 0.01, then you reject at 5%. Okay? So you would say the man and the woman are very different in this model. And the implication would be you probably have to design, in my application, 2 different marketing technique for 2 different group of customer. You should segment the market, right? So that is a very useful technique when you talk about marketing. Okay? And also you can do critical value method, right? And just let me quickly do it here. The critical value will be asking the following question: TATA 0, right? What is this? Area 0.025, 0.025, right? And this will be T inverse 0.025 ATA, and this will be T inverse 0.975 ATA, right? And I think that is something close to 2. It's 1.98, right? Very close to 2. So this negative 1.98 and the positive 1.98, right? And you have negative 2, so that's your data is actually here, deep inside the region, right? So you will reject because it's in the green region, right? So regardless of your p-value or critical value method the same, okay? And in a lot of Python or R package or everything, they will give you both things. Critical value, give you the t statistic and the p-value. 3 of them will be given. So you would pick, you can make your decision. Okay? So very last, before the break, want to talk about the very last thing, right? This is, I have the hypo testing, right? The difference. Now, of course, I also want to do estimation, right? Want to estimate whether they're different or not. Okay? And the formula, if you look at the slides, will be x1 bar minus x2 bar, right? Actually, this is negative 2. This is your best point estimate for mu1 minus mu2, right? So this is the best estimate for mu1 minus mu2, right? That's the best guess, right? But also I want confidence level as well, right? Because this is 1 point there. Then it will be x1 bar minus x2 bar, right? Plus minus t, xt8 alpha over 2, right? You just take the standard error, just this guy, right? Maybe this will be just 1.987, which is critical value here, okay? And just denominator, okay? And this would be your estimate, right? You give the range where how woman different from woman, right? So I hope now it's clear what we're doing, okay? After the break, we'll drop the assumption that sigma 1 square equals sigma 2 square, okay? Then you will see we will have a different denominator formula, okay? Because we can't combine. So simply we just S1 square, S2 square, okay? The only difference, the difficult part is, what is this guy? What degree of freedom? It's not N1 plus N2 minus 2. It will be something, the most ugly formula we learned in this course, okay? You see it's a humongous fraction, but I just provided there, but usually is you don't actually calculate that, probably except for your assignment. I don't think I will ever ask in the exam, but that will be the assignment will be asked. Then you will have to check out that one, okay? And then we'll talk about that after break. And then there are a few more tests there, but shouldn't be difficult. But it will be very similar to what we have already, okay? So hopefully you will see how we actually from a 2 sample case actually go back to the 1 sample. Very similar, right? At the end of the day, just like 1 bell and do the same procedure. Okay. um, no question. Or you have question. It's easier to say by you reply. So I will see you in 15 minutes. So I guess we can slowly resume as we look at the your feedback. First, almost weekend. Yes, I can't. Thank God it's Friday, right? I think everyone would happy because now is actually Friday. We can't rest because there's so many things to do as the semester ends, and I also have a lot of things because I also have to make the exams, right? Have to grade all your stuff. Okay. And someone asked the format same. Yes, will be very similar. And this year, I'm thinking to add a few multiple choice question. Because I figure out that some of the students actually don't know very well for the short question. So probably I add some multiple choice questions so that you can get some marks. So I just try to add maybe five or six, a few multiple choice questions. So at least you don't know anything. At least you can write A, B, C, D to get some points rather than someone get zero. So I don't want zero to appear in your exam. Actually, one or two students actually get zero in the even open book. They get zero for the exam paper you saw. So I hope at least that will be different. But otherwise, it will be just basically three questions, uh, and then will be multiple choice question. So that would be something like that. And then multiple choice question will be should be easier than the quiz I give. Okay, so should be easier than the quiz I give, or some similar level. Will not be more difficult than the quiz. No. When is the deadline of the project? Um, do I give it already? So the project PDF will be the end of semester. Okay. Uh, so you will be 29th. Okay. The exam is over 26 and 29. Remember, you only do one A4 paper, both sides for each one at the maximum. Uh, right. Only one A4 paper for per each group member. So you have one person, just one A4 paper. Two person, two A4 paper. Okay. Of course, if you want to put extra material, you can put appendix. But I would just mainly read your main thing, and then if I don't understand, I can check your appendix. But I mean, the main thing is you have to convince me in the main page limit. Okay. And I make it like page limit is very little. So basically, you can just make sure that you put the most concise thing there. Okay. Um, what for breakfast for me? Uh, I just have cappuccino and that's it. So I have no dinner last night, and then I have only because I'm teaching at night, so I didn't eat anything. Uh, and then this morning, nothing. I wake up and just bring the kid to the school, and then coffee down there, and that's it. No breakfast. Uh, so I don't have any food for like 10 hours. No, more than 10 hours. Right? It's like 23 hours, 22 hours. It's okay. Uh, I have so many fat in my body, so can consume some of the fat. So that's it. Not recommend for you to follow this, but when you get older, then you like this. Okay, you don't have to eat that much. Um, Friday, yes. What's the weather today? Yes, it's rainy. I'm surprised who says sunny today. They must be not in Hong Kong or maybe in somewhere else in the world. Someone in the other side of the world attending our seminar. But I'm not sure any way we can say sunny. t-test, yes. That's good. And the speed is okay, I guess. And I think most of you can still follow. Well, so we have something like this. Okay. And at least some of you are not so tired, but more than half is very tired, especially it's Friday. And I hope you take a good rest. May I know, can we bring? Yes. You can bring as many as you want, as long as it's paper. Okay. Low limit. Okay. Can be handwritten, can be computer written. I mean, it's okay. I mean, you and your friend make up a one cheat sheet, right? You can then can easy, right? Can some of them is very good at doing note taking, right? They can make a very good notes, okay? Or you can print out all the slides and bring, okay? Whatever you like, no limit. But my recommendation is not to bring too many because you have to have the time to figure them out, right? But you can bring as many as you want. I mean, I don't have limitation. Yeah, get well soon. Yeah, I'm sorry that I've been sick for until now. I'm still a little bit occasionally coughing. I apologize for that, uh, but I think I don't have any disease now. But I think it's just the uh the lung or it's not fully recovered. But I don't think I carry any disease at the moment, so should be safe. Now, if there are no further question, then we continue our journey. Is the following is we would drop the assumption that the variants are the same. Okay. The only difference is now we no longer have SP, but we just S1 and S2 here. The only complication is which table to check. Okay. Which table to check. All right. So actually the same as look back the white board here. Actually, the very same thing. Okay. The only thing we don't have SP. Okay. The SP squared no longer valid. We just use different number here. Okay. And that means that we no longer can use 88. Okay. Will be another number. And turn out that, sorry, this number, the degree of freedom, or which t-table to check, the V is coming from a super complicated formula. Unfortunately, is coming from this most ugly formula, which I don't have explanation for this, okay? Because this come from very complicated calculation that only actually appear in 60s ago, 1950 something. Someone proved it. So it's just but it is actually automatically calculated in any software, okay, even Excel. So you don't have to worry about this, right? It's related to how big is your sample variance, how big your sample size, and this formula, I don't have a good intuition, and so just some formula, okay? So let us look at this one again, okay? Very similar, but now we no longer assume that. So let's look at this again and check out whether you get it or not, okay? So again, look at men and women, but now we're unable to assume that they're the same variance, okay? Again, women want to spend on average $40 on your product, okay? And the sample variance, so sample SD is 4. How many women you ask? 50. Okay. And you're asking men, how many was the man average on your product? 42. Standard D of the man is 3. How many men you ask? 40. Okay. So this is the setting. Okay. The data you got. And remember, what's the goal? You want to see if man and the woman have same willing to pay for the product, and if they're not, right? So that is very useful question because again, you want to see if you want to segment the market or not, right? And now we no longer have this assumption. They're not equal. So we are not allowed to use the nice formula. So we have to use more complicated formula. This is more general, so we require a more complicated formula. So remember all x1 and x2 are bell curve. So that's what we have. X1 bar minus x2 bar is still a bell curve, right? Because x1 bar is a bell, x2 bar is a bell. The subtraction is also a bell, right? The difference of the two bell is also a bell. And the center of the bell will be mu1 minus mu2, right? Which is 0 because of this, right? Because of the assumption that they have the same mean, right? We want to see the same mean and then whether see the data support or not, okay? And the variance is just adding up, right? If you remember, the variance of two independent variables, we're just adding up their variance, okay? And then again, you want to check against this guy. So you will reject on the both side, which is alpha over 2. Alpha is often 5%. Now the question we see is from the data, woman spending 40, men want to spend 42. So the difference from the data is -2, right? -2 here. So the question is -2 is it in the orange region or not, right? So which is the case? If in the orange region, we reject, right? And if you know sigma 1, sigma 2, then it's done, right? Because the bell curve, we know how spread out. We can calculate by the z-test, okay? But in general, we don't know. And we will replace it by S1 squared to this one, S2 squared to this one. But once we replace this, we need to check the t table, right? Because that's what we say, right? It's normal if we replace the population by this, we look at the t table, okay? But t have to be something very complicated formula, v, okay? But at this will be 0, okay? And what is the green area there, okay? This will be just -2 minus 0, right? Because the t-test, right? T-test. And you replace by this, right? So it is square root of 4 square, because S1 square over 50 plus 3 square over 40. Okay. So that will be the t there. That means -2 will be, what's the number? 2.7. Okay. So this guy is actually -2.7. Okay. Nothing new, same, we're similar to before, but we no longer have SP square. So we just with S1 square, S2 square, because they're not the same. We can use cannot the same one. The difficulty lies on what's the V. Okay. In this particular, V will follow a most ugly formula we have ever seen in this class. Okay. And not going to write that down because that will cause us a nightmare, right? That means that if you can't sleep tonight, okay, even though you're tired, write that down for 10 times, the formula, then you can easily go sleep, right? So this formula tells us is calculate 87 point something, and you run down, so take the smaller one, 87, okay? So this V tell us that actually look at T87, so, and don't worry, usually this come from your Excel formula or your software package give you, okay? So probably accept the assignment. I will not ask you to calculate this guy. I make sure that this time I don't ask for the exam, okay? I mean, if I ask you, then probably you can just give me the Excel formula, then it's fine. Okay? Because Excel can directly calculate this one. I'll try to make sure that it will not happen because I think this is too crazy to calculate by hand. I mean, of course, it's not something deep, but I don't want to ask exam because who has better calculator skill? Right? Remember, you can bring calculator to exam. Okay, but I try not to ask too many calculation in the exam because there's no point to ask calculation, right? Because everyone look at the Excel anyway or calculator anyway. So what you want is to look at this p-value, right? Because this area times 2 will give us the p-value, right? Because that is you're adjusting the alpha just to reject it. That's the p-value, right? And because it's alpha over 2, so that's why you multiply by 2. So what is this area? Will be t, this -2, 87, true, and times 2. This is the p-value. And sorry, not -2, -2.7, -2.7, sorry. My bad. It's -2.7. Okay. And the answer from the slide is 0.8%. So this is 0.08. Okay. So that means that this is less than 5%, 10%, or even 1%. Right? So that means that you will reject the directional, okay, at even 1%. Okay. So they are different enough. Okay. Okay. So you would say again, you would have a different marketing technique for different market. Okay. And of course, you can also do critical value, which I quickly do it here. Right. This will be T87, right? The critical value 0.025, 0.025, right? This will be T inverse 0.025, 87, and this is T inverse 0.975, 87. Okay. And these two numbers are 1.98. Okay. And your data is -2, so it's inside. Okay. So you would reject in this, okay, as well. Okay. And next, last thing is if I want to do the interval estimation, right? If I want to guess what is mu1 minus mu2, right? What's this guy? Okay. The point estimate will be x1 minus x2, which we know -2, right? If you want to guess what difference of men and women, will be just $2, right? But if you want more, you want to say this, right? T plus minus T 87 alpha over 2, right? Standard deviation will be 4 square 50 plus 3 square 50, right? And remember what this guy is actually the same as this guy, right? 1.98. Okay. So actually the critical value in the two-tailed test, as we know, is actually the T and the Z actually be used for the interval estimation. Okay. So always actually they're related. And actually, if you look carefully, that's how interval estimate and two-sided tests are related. Okay. But if you go to stat department, they'll ask you this. But since we're B school, we don't really care. Okay. Just telling you how to estimate. Okay. It's 1.98 if you want the number. So this would be the your guess. Okay. Is that okay? Any further question. Any further question? No question? If you don't, then I will immediately jump to the thing that I think is one of the most interesting thing. Okay. Although very simple, but it's very interesting and very useful. So far we compare two population, and the two population, boys and girls and men and women, are independent, right? So telling you something about the man, don't tell the woman, right? They can just compare two group. And here we have a even more detailed data, okay? What we call the paired population, which means that each item in the two population can be paired and the same individual, okay? You can imagine the following. The question like this. I have population 1, okay? And I have population 2. Okay? And here is the question, okay? I have girl here, a woman here, okay? And I also have the same woman here, okay? And the same individual, okay? And probably, okay, this is the case that, okay, case number 1 is he's single, she's single, and case number 2, then she is actually have a boyfriend, okay? What I'm testing is, now the boyfriend, is she more happier than compared to single, right? And again, I can have this same woman, okay? Same woman number 1, woman number 1, right? And maybe, and I have a guy number 1 here, right? Guy number 2 here. I know a guy number 2 here, right? Then maybe he also met a new girlfriend, right? Not the same, but another girlfriend here, right? And want to see whether getting into relationship is getting him happier, or look at the GPA, right? After he has a boyfriend or girlfriend, his GPA go up or go down, right? Maybe they study together, or maybe they go to cinema together, right? Don't study. So the question is whether getting into relationship, a romantic one, would change their GPA, right? So how you see this is, see if the same individual, look at the difference, right? If the difference is different from 0, they're different, right? So in this case, the GPA or happiness is 1, 1, right? X11. This is X21, and this is X22, X21, and this is X22, right? We define the difference is X11 minus X21, and D2 will be X21 minus X22, right? Just look at before and after, right? The D, right? Maybe this D, we're going to see whether the test is mu D is 0, right? Or mu D is not 0, right? Of course, that means that mu1 equal to mu2, right? Because there's an average on that side, okay? And you ask, why we care about whether someone have a boyfriend or girlfriend? But that is exactly what we call A/B testing. Imagine the business, our application is, you have a new old website, and how they like your old website, how many times they spend on your website, and then you have new look, new system, right? And see how much time they spend on your system, right? And or you have a new product, an old product, right? You expose them and see if they're different, right? then actually they do a lot of A/B testing. Say, Meituan, Alibaba, Amazon, every day they run thousands of tests. This is called A/B testing. Okay. And actually, one very famous experiment called the bean experiment, the Bing experiment, okay, is by, actually you will see, let me show you. We have a famous experiment. So you see here, this experiment like this. You will see, actually you have this line, right? The flower. And you will see file delivery, blah, 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 right? And actually, why you have seen all this kind of thing after this, say, you will see after this, you have a subtitle here, okay? And actually, this come from, we keep a long, very long thing, right? It's unrelated to this. Is this is a description of the main thing here, okay? And actually, this come from an A/B testing, as we've seen, is by moving the first line to here. Okay, this is actually the first line of the website usually, and especially go to Google. Let's show you to Google. You see, have a dash over there, right? And you have many ad there. You will see a lot of ads uh, have this kind of nonsense second line, okay? And they do A/B testing. Population one only have this without this, okay? This is advertising, right? Turn out that if you put advertising, same as here, they increase the revenue by 10%. That means for Microsoft, the Bing, they increase the revenue by 100 million each year. Just simply by moving this, right? How Microsoft or Google make money is, you see the advertising, click on that. Simply by moving the first line there, they earn 100 million more each year, just in the US market, not globally. So just very simple. How they can test this is do the A/B testing, as we said. Just do this. Case number one, they only have a company name. Case number two, company name and their first line in their slogan, advertising word. Okay? Instead of putting line below, you put it on the same line. And this make people click more. They can make millions or more dollar. So that's the power of A/B test. And then you learn this is you go to marketing. I think you go to marketing, they got A/B testing. There's something very important. Okay. So once with this, then how can you test this guy? Because D, we assume is normal, then we're done, right? D is 0. Okay. And this is the standard deviation from D, right? It's D over N, right? You assume this is normal. Okay. And because we don't know this, we just use the simple t-test, right? So just say one sample t-test, right? The difference is your data. You just do a t-test there, right? You just do a t-test there and then see if this is alpha over 2, right? And you do t n minus 1, right? Say. Because you can pair. So n means n1 plus n2, right? In this particular case, n1 equal to n2. Just make sure that this case n1 equal to n2, right? Because everything can be paired. Equal to n. Okay. So without further ado, let me show you the example that that's the case. Okay. So as I said, this is the most useful tools that actually use in business. Okay. You do A/B testing, you do compare and control. I use the medical, but you can imagine this is the Bain experiment. Okay. So we have the control treatment group. Okay. Control means take no drugs. Treatment take drugs. Okay. And we want to see whether the drugs has effect or not, because in medical, right, you know that even you do take the drugs, your body has a recovery mechanism, right? You can recover. So assume normal. It means that the difference also normal, right? So before we do anything, we know the D bar is also normal, right? And with the mean 0, sigma square over n, right? Right. The difference in the mean, right, will follow the bell curve, right, with the mean sigma. Okay. And of course, it's two-tail test. So we reject with alpha over 2 here, alpha over 2 here. Okay. And what is left is, okay, from the data, the difference is 1. Okay. On average, the treatment of taking a drug is actually 1. So the question would be, is 1 here or 1 is here? Okay. Is it 1 far away from 0? Right, again. Okay. And again, if you know sigma square, then we're done, right? Then just the bell curve, everything is easy. But we don't, then you have to use the standard deviation of your difference to estimate, right? So you look at the difference between each data point, right? Pair, first woman, you have the number, first man, second man, you have the woman, and so on and so forth, right? All the data, all the difference, you can calculate the sample SD, right? And then it's 2, so that means that you can do the T. T is 15, right? Because sample size 16, right? And then you have the bell curve 0 again. Okay. And what's the 1 here? 1 will be what? Will be 1 minus 0. The sigma use 2, right? So remember, this is this, and then that means that SC is sigma over root n, right? So that means it's 2 over root 16. Okay. And 2 over root 16 is our friend 1/2. Okay. So that means that this is 2. Okay. So the question is asking, is 2 far away from 0 under T15? And the answer would be this area times 2, right? And this area is what? It's T, this 2, 15, true. But this is just the left-hand side. This is right-hand side, and this times 2. Okay? So this is the value. And this value is 6%. Okay? So if you 10%, you cannot reject. Okay? You can't say the drug has useful or the change is meaningful. But if you use 10%, then you say the drug is good. Okay? You don't need more, right? You don't need more data. Okay? It's good enough to say there's a treatment has some effect. Okay? That's actually applied in many practice, right? Actually, many people work daily is doing this. Okay? In the Amazon, in a lot of online website. That's why you can see a lot of changes in many websites. Is applying this practice and do the t-test. That's famously called A/B test. Is that okay? Any question? Because the difference follow normal. So basically, we just know there's no difference, although we say two sample, but it's a difference in matter, right? Because we define the difference is the variable we care, right? Right. The D it's just the difference between this mean, right? Each observation. But you will see how to do it when you look at the assignment. I will ask you assignment in this one. Okay. Any question? If no, then let me go to I'll save the F test for next class, but I will quickly go over this one because it's very similar. Remember, we have proportion actually follow the Z test. Okay. That means that the difference in the proportion will be also following the Z test. Okay, same as the things we have seen. Okay. Let me go over that again quickly. If I don't have enough time, then I just stop somewhere in the middle. That's okay. So we know the proportion of 1 will follow the bell curve, right? By looking at this pi 1, right? Will then the variance pi 1 minus pi 1 over n1. Okay. Remember what this is. I asked how many girls like the pop star, right? Like the Korean pop stars, right? That's proportion, right? And I can also ask the men how many of them would like the Korean pop stars, right? And that will be centered at pi 2, right? And the variance of pi 2, almost pi 2 over n2, right? So that will be the idea. And the idea is I want to test whether pi 1 equal to pi 2, right? Is it any different between men and women are different in terms of liking their Korean idol, right? And why I want to do that? Because of if they're different, then I would use different marketing technique, right? Not the same. Right? And that means the two bell, the difference will also be the two bell, right? And the variance add up, right? And if under this case, this is 0. Okay. And again, you ask the data, the sample proportion, is it going to be this over 2, right? So at the end, you will see, use the Z test, right? To put that in, okay? And in the next class, we'll tell you that very interesting case is, since assume the same, okay? We can have a better estimate for pi 1 and pi 2, right? Because this, the best guess will be P1, 1 minus P1, right? And this will be P2, 1 minus P2, right? Okay. But turn out that the better way to guess this pi, because under the same, the variance actually the same as well. So there's some way to guess in the formula. Okay. We'll talk about this in next class, but this is just standard Z test. Okay, with a modified variance formula. Okay, and that is better, help us better tell the answer. But this is standard Z test. Okay, although the assignment released, but I think just one or two questions in the front cover, you can start doing this over the weekend. TA will release the So I guess we can go now because you can enjoy your holiday earlier, 1 minute earlier than we do, but because we're delayed sometime. Okay. Have a nice day. I'll see you next week.